Hi, everybody. Thank you for joining the Synthetic Intelligence Forum. My name is Vic. I'm the founder and the host of the Synthetic Intelligence Forum. Today, it's my absolute pleasure to welcome to the forum Professor Muhammad Mamdani, who has a number of appointments and affiliations with leading centers of research and scholarship applied to the intersection of healthcare, medicine, artificial intelligence, data science, education, and science communication. And without further ado, Professor Mamdani, I'd like to welcome you to the Toronto Synthetic Intelligence Forum. Now, before we dive into your content, I'd love to just ask you to tell us a little bit about your affiliation.
Sure, thank you. It's a pleasure to be here. I have a few affiliations. My main role is Vice President of Data Science and Advanced Analytics at Unity Health Toronto. Unity Health is a composition of St. Michael's, St. Joseph's, and Providence Healthcare in Toronto. And I head up a team of about close to 30 data scientists whose goal really is to develop and deploy solutions, many of them using artificial intelligence, machine learning, to drive patient outcomes and hospital efficiency. I'm also the director of the Temerty Center for Artificial Intelligence Research and Education in Medicine, or TCARM, at the University of Toronto. We're the first AI medicine center of its kind in the country. And now we have a network of 23 universities across the country, all focused on AI and medicine. I'm also a faculty affiliate at the Vector Institute, which is a leading artificial intelligence institute, globally renowned, fantastic place, and an adjunct senior scientist at ICES, or formerly known as the Institute for Clinical Biosciences. I also hold a professorship at the University of Toronto in medicine, pharmacy, and public health.
So great to meet you, Professor Mamdani, and the floor is yours. Take us away. Thank you.
Great. Thank you so much. So I'm going to talk a little bit about applied artificial intelligence. Research, yes, but applied as well in terms of how we actually see these things in clinical practice. And I'm going to really focus on the Toronto landscape. I just have a few objectives, really. The first is to provide an overview of data-driven challenges in healthcare. Second is to provide an overview of the AI medicine landscape in Canada with a focus on the Toronto environment. And third is to provide an overview of the applied AI program at Unity Health Toronto. I'm going to step back a little bit and marvel about the miracle of modern medicine, how it's just incredible how we can give the gift of sight to those people who may not have been able to see in the past, where people in car crashes, where we would have deemed there's you're never going to be able to walk again. We're able to give them the gift of being able to walk and be with their families and active. Cancer, certain types that would have had people die within weeks to months just 20 years ago. Now we're able to extend those lives much, much longer. So it's incredible how much medicine has been able to accomplish, but it's complicated. If you think about the human body, it's composed of cells, right? How many cells? These little things that have tons of processes in them, about 70 to 100 trillion cells in the average human body. Now, each of these cells, if you go in and look deep, there's about 100 trillion atoms within each of these 70 to 100 trillion cells in the human body. And all it takes is for one thing to go wrong. If you believe in chaos theory and the butterfly effect, one thing to go wrong and then you have disease. Sir William Osler was famously quoted as saying, "Medicine is a science of uncertainty and an art of probability." Why? Because we don't know as much as we'd like to know about medicine and health. There's some popular statistics out there that we know of about 10,000, maybe 30,000 diseases. The reality is that that's just the tip of the iceberg. These are diseases that we know of. There are lots of other things that we don't know of. And if we look at how many treatments are actually approved for these 10 to 30,000 conditions, it's only about 500 of them. Just a fraction of these conditions actually have treatment. So how much do we really understand disease? Not as much as we would like. We're getting better. When we think about the art of medicine, it goes from diagnosis to prognosis to treatment, right? That's typically the pathway you follow. In making a diagnosis, you kind of consider a whole bunch of things. Some diagnoses are very simple, others are not that straightforward, but it requires processing a lot of information in our heads. Patient history, social history, labs, vital signs, medical imaging through x-rays and such, and put all that in our head to say, I think this patient has this diagnosis. And for certain conditions, we're not that great at it. So we don't get it right all the time. In fact, there have been several studies in several conditions that suggest that in some fairly common conditions, maybe as high as 20, 30% of patients who are diagnosed with a certain condition may not actually have that condition. We didn't get it right. So of course, then once you've made a diagnosis, you say, well, how am I going to manage this patient? Am I going to be really aggressive because I know this patient isn't going to do well? Or am I going to be a little bit less aggressive because I can give them treatments that don't have as many side effects or a bit easier on them because I know they're going to be okay? The prognosis of saying, are they going to do well or not do well? We're not very good at. There's study after study after study showing how terrible clinicians are at prognosis. And then, of course, there's treatment, because treatment is dependent on the prognosis in many cases. But there's a further complexity around treatment. If you look at disease like multiple sclerosis or even depression, there are many treatment options. And do we know exactly which one to pick when? We don't. The reality is, in a disease like depression, for example, many clinicians will use a class of drugs called serotonin-specific reuptake inhibitors. There are multiple choices. Which one do you pick? In many cases, you kind of think, oh, let's try this one, see if it works. And if it doesn't, you try something else. That's kind of how we do things. There must be a better way. All of these things, though, are driven by data. When we make a diagnosis, we're processing a ton of things in our heads. When we look at prognosis, we're trying to predict or guess based on a ton of information in our heads. And when we look at treatments, there's a ton of processing that goes in our heads in terms of what would be the best one. Unfortunately, we're not very good at handling all of that data and all of that information. And it is all that data. Healthcare is very rich in data. So if you look at the compound annual growth rate for data, healthcare outpaces every other sector. So it's not like we don't have enough data. We have a lot of data to work with. Here's a problem. What clinicians want, we want the best possible care. We want the best care for our patients. But we need to keep on top of the latest research findings. What we struggle with, though, is to do that. A new study is published every 2 minutes. There's over 30 million studies that have been published. We don't have the capacity to go through all of them. We have to constantly monitor our patients. And we know that the average physician may spend less than 15 minutes per day reviewing a typical patient. We have to process an incredible amount of complex information, as I alluded to, but the average human can only process 7 plus or minus 2 things at the same time. The issue is that a complex medical decision often involves processing about 1,000 different parameters. So clearly there's a mismatch in terms of how much we can what's humanly possible in terms of us being able to handle versus what's needed. Now, of course, we need to also assimilate all the right information at the right time for the right patient. That's hard. So what does that mean for practice? We don't do as well as we could. Some of our statistics are that over 30% of patients do not get treatment of proven effectiveness. Over 20% of patients get care that is not needed or even potentially harmful. That's a lot of people. So do we have help? Can we get help? You may see these headlines in newspapers. When do we admit Canada's healthcare system just isn't working? Wait times for medical procedures at 20-year high in Canada. Nearly 75% of Ontario doctors experienced burnout during the pandemic. 90% of nurses considering leaving the profession the next year. But every now and then there's a glimmer of hope. Titles like how AI is helping shorten patient wait times. So there are things that are out there. Yes, it is a very, very tough environment to be in. But I do think there are things that can help us do better, especially when we are so data-driven these days. So in terms of activity, with respect to AI and health, if we look at academic productivity, it's skyrocketed. It's grown exponentially, as you can see from this graph. In 2005, there were a couple hundred papers that were published. And if you fast forward that to about 15 years, not even 15 years, it's grown to over 12,000 publications in a given year. So massive uptake in terms of interest and excitement in this area. And in terms of which areas, pathology, radiology seem to be the big ones, surgery, psychiatry, basically all sorts of disciplines in medicine have been really embracing AI from the research standpoint. Now, how is that actually translated? There's been some commercial solutions out. If we look about 20 years ago, There's only a couple, maybe. Now, in recent times, over the past, I would say just 4 or 5 years, we've seen a few hundred solutions become available that were FDA approved. So we're seeing more and more solutions coming into clinical practice now through FDA approvals. And of course, what people have said is that the market size for healthcare, AI in healthcare is increasing quite a bit as well. If you look at 2021, just last year, it was projected at about 11 billion, whereas in 2030, literally about 7 or 8 years from now, it's expected to grow to almost $200 billion. There's a survey that was conducted a few years ago of 200 US healthcare decision makers, and this was a few years ago, right? Some of the survey findings were pretty interesting. 91% of respondents believe AI will be used in clinical decision support. 84% believe companies who do not invest in AI will fall behind. 83% believe AI will improve the accuracy of medical diagnoses. But here's the kind of one statistic that I walked away with that was pretty interesting. Over 1/3 of participants said that they're already using AI. Over 1/3. This was a couple of years ago, and you've seen the exponential growth. It's not something we're just talking about. It's something that's actually happening in our healthcare system. So what does the AI medicine environment look like in Canada? We have incredible data assets from leading groups like ICES, which holds data in Ontario for 15 million people. Genome Canada has terrific strategies around data. We have initiatives like the Health Data Research Network of Canada, Alberta Health Services, in terms of provinces taking matters in their hands, saying, no, you know what, we're actually going to try and unify the health data in our province in a very disciplined manner. Individual institutions that are leading in this space, like SickKids. We have quite a few data assets that are incredible, but we also have a lot of good technical expertise. In Canada, we have the Vector Institute in Toronto, Mila in Montreal, Amy in Edmonton, really world-leading institutions of AI, with many of them actually having a focus in health. And of course, collaboration. We've got lots of pieces. How do you bring everyone together? We now have an AI in Medicine Center housed at the University of Toronto called the Temerty Center for AI Research and Education Medicine. And we formed a fairly large network of universities from all across the country to bring people together and work together. And of course, there's translation. We see some leading edge companies like Deep Genomics, Blue Dot, a recent one that was launched earlier this year that I'm involved with is Signal One, which I think is going to be very exciting too. And we have individual hospitals and centers like Unity Health doing some pretty innovative, groundbreaking work in applying AI into medicine and clinical practice. The University of Toronto environment in particular is quite exciting because if you look at our university, we have world-leading expertise. In statistics, I think we're top 10. Computer science, we're top 10. Engineering, we're top 25. In education, we're top 5. In medicine, we're top 5 in the world. All of these really excellent programs in schools, the ones in red, stats, comp sci, and engineering, are critical to the technical side of AI. And medicine, of course, is contextual. And of course, education is incredibly important. We're top ranked in all of these areas. So it's basically a very perfect storm to be world leading in applied AI in health. And we have institutions like ICES and the Vector, which are world leading in what they do. It's a perfect environment. But the nice thing too is that we have a really good hospital network. We have the Toronto Academic Health Sciences Network with many, many academic hospitals as well as community hospitals, really forming that nice natural environment for bringing technical into clinical. There are lots of examples of great work that's being done in the Toronto community. So for example, at the Toronto General Hospital, researchers are looking at, in the area of lung transplant, how do we predict 1 in 5 year survival with likely causes of death? Because patients who undergo a lung transplant have high mortality. But they're able to predict this patient's going to be really at high risk and maybe of high risk of cardiovascular causes. So maybe we need to actually manage that better. Incredible work going on there. If we look at breast cancer, at Sunnybrook, researchers have an algorithm that predicts response to chemotherapy with 96% accuracy. What currently happens is many patients do well on first-line chemotherapy, which is wonderful. But there's quite a few patients who don't. And what happens is you actually cycle through some time and realize this isn't working. And then you try another regimen, and you try another regimen, and months can go by before that patient gets the right treatment. And it's algorithms like this that could really advance care. There's some really interesting researchers over at UHN, University Health Network, looking at laparoscopic cholecystectomy and AI-guided surgery. If we look at this video, it's kind of interesting. What this thing does is it actually highlights green areas as you're cutting in real time to say these are the areas that you should be okay to cut in. The red areas, don't cut because it's a higher probability of a major bile duct injury. So it kind of guides the surgery as it's going using AI around areas that are okay versus areas that are not okay in terms of making cuts. So again, some very exciting work. The problem is all this work is being done in silos. So how do we all talk to each other and share our learnings and make each other better through our understanding and collective collaboration? This is where the Temerty family had made a very generous donation to the University of Toronto, over $20 million dedicated to a Center for AI in Medicine. And that's what the center does. It actually brings people together so we can actually learn from each other and collaborate on things. The way we're structured is we have 3 themes: an education theme, but we have a leading lecture series that happens monthly where we bring in world-renowned speakers on a monthly basis so we can all learn from their wisdom and their insights. We have learner series where we bring together students in medicine, in computer science, and engineering, and statistics, where we're all learning from each other. And this happens on a regular basis as well, where 80 to 100 students will show up in a session, and there'll be a presenter in the medical area, in the medical discipline, and then there'll be a non-medicine technical student who will present their perspective on things in, let's say, engineering or computer science or statistics. And again, this multidisciplinary approach really, really helps us learn from each other in an effective manner. Studentships, I think this summer we're offering 30 studentships for students to be able to get into this space, and workshops and training opportunities, lots and lots of stuff going on at the education end, all coordinated by TCARM. Research in terms of education AI innovation grants. We've had 2 that were given out recently last year. This year, we're going through an exercise to look at really translation types of activities as our core research granting opportunity, but also funding, again, more innovative type work. These are just a couple of examples of the types of work and people that have been funded doing very exciting cutting edge stuff. And of course, then there's infrastructure. It's hard to do AI without data. And so do we actually have an environment that is usable by pretty much anyone in the academic space? Not really, not a good consolidated way of doing things specifically focused on AI in medicine. With the tools that we need, with the flow that we need, it didn't really exist. So we actually ended up creating the Health Data Nexus on Google Cloud with virtually unlimited storage, virtually unlimited compute to be able to actually provide people the environment they would need to do this work effectively. Again, we're very excited about that. Of course, nothing happens without community. It takes people. So in terms of community, we have about 1,000 members across the University of Toronto and affiliated GTA institutions or Greater Toronto Area institutions. And we think it's through our community that's going to drive that culture change that's needed to enable AI in medicine. We have initiatives like the Collaboration Hub, for example, where it's like a Kijiji for AI in medicine. Anyone can fill out a form, a one-pager that says, hey, you know what, I'm a neurologist at Sunnybrook Hospital. I've got access to 4,000 head CTs, but I don't really know how to build neural networks or 3D convolutional neural nets that I would need. Is there anyone who could work with me? And that posting goes to our 1,000+ members, and people can raise their hand and say, actually, I'm a computer scientist with 2 funded students. I don't need funding. I just need data and clinical expertise, which you have. Why don't we work together? And so in our early days, we've had about a dozen of these submissions. We've already matched about half a dozen, and we continue to match more, just bringing the community together. Hive Hubs is something that we've launched, soft launch. It's going to be hardware launched very soon, where basically anyone can start up an interest group. So if you're interested in a particular space of AI in medicine, you can actually put out a call and say, why don't we all get together and talk on a regular basis? And we'll be able to share our insights and learnings and advance the area that I'm interested in. So for example, somebody's interested in AI and irritable bowel disease. Well, great, form a group, have 20, 30 people in there that meet regularly and actually advance the field in terms of research, in terms of education. Those are the things that we really want to see. And of course, as I'd mentioned, we now have a network of AI medicine, 23 universities across the country that are actively involved. As far as I know, this is the largest AI medicine network in the world. Again, very exciting. And I would encourage everyone to learn more about TCARM by going to this website. We also have memorandums of understanding with Technion University in Israel, and we're exploring a few more MOUs with international universities to actually expand our scope just beyond Canada and be more global. We're also part of something called the Alliance of Centers for Artificial Intelligence in Medicine, or ACAIM, which I think is fairly exciting. It brings together a whole bunch of AI medicine centers from all around the world to basically catch up and see what we're doing. So lots of learnings here. And in May of this past year, we were very fortunate, TCARM was, to be named the Institution of the Year, which again, I think is very, very exciting. So internationally recognized, and because I think the talent is here in Canada, and it's great to be recognized by such a terrific group of people. I'm going to now start talking a little bit about going from research to practice, that whole practical side of things. And I just have to say, when we're talking about AI medicine, it's often glamorized. But when you go to deploy these things in actual clinical practice, it's not really pretty. It can be very, very challenging. So there's a nice study, for example, that was published just recently around this group did a systematic review, and I think they looked at over 400 studies of AI models and solutions specifically focused on COVID. And the lens that they took was how many of these publications and models could actually be deployed into clinical practice. And the answer was none of them. Because the research environment is very different from the application environment, and that's something that we need to get our heads around. So just a quick kind of synopsis in terms of where I'm from. I'm based at St. Michael's Hospital of Unity Health, but I'm part of the Unity Health ecosystem. And St. Mike's, I'm going to just focus on this hospital. It's a tertiary care teaching hospital in downtown Toronto, established in 1892. We basically take care of the sick and the poor of Toronto's inner city. We're one of 2 adult trauma centers in the Greater Toronto Area. We have about 500 beds, over 6,000 staff, over 900 physicians, over 1,600 nurses. Our approximate annual patient volumes, over 75,000 emergency department visits, about 80,000 these days, over 500,000 ambulatory visits, over 25,000 inpatient visits. Why am I telling you all this? There's a lot of data, especially if you multiply that by 15 years of historical data, you have a lot of data to work with. We have a research institute, and we're fully affiliated with the University of Toronto. So what we did was we actually created an AI lab. Right? This is what some hospitals do, is they actually said, bring in data scientists. But we went one step further. We actually created a robust data environment enabled that enables our data scientists to be able to do work in AI. We brought in all sorts of tools, Python, R, PyTorch, TensorFlow, Garobi, all sorts of tools to help our data scientists do their job. And we also brought in hardware and software that would enable them to drive things. So for example, we have servers with GPUs with sufficient compute power for our purposes. But we didn't stop there. Because one thing that I quickly realized was, if I have a non-clinician, it's really hard for them to really understand the nuances of medicine. So our model is very simple. Our data science team does not ask questions. The questions come from our frontline workers, our staff, our folks who are engaged in patient care and administrative decision-making day in and day out. They're the ones who get to ask the questions. Now, what we do is we bridge the two groups, saying, clinicians, frontline folks, you guys have the expertise in what you do. We have the expertise in AI and medicine. Why don't we work together? So it's very much a collaborative model where we all work together. The way we're structured is that I head up this team, and we have core teams, the data integration and governance team. This is where we are able to get access to our messy, dirty data and our source systems. We have over 50 of them just at St. Mike's alone. So you can imagine the data engineering it takes to get all of that data out in a usable way that's amenable for AI. So we have a whole team dedicated to ETL development, data engineering, that sort of stuff. They're the data integration governance team. Then once we've grabbed our data, and for many of these things, we grab our data in real time, we actually have algorithms to clean and scrub them in real time. And it gets fed to our advanced analytics team, which develops the models. So here we have our computer scientists, our operations research engineers, our statisticians that actually do the model development. Because a lot of their time often goes to data cleaning, and we'd rather actually take some of that burden off through the data integration governance team. Now, the advanced analytics team will build our models, right? But what about deploying them into practice? This is where we have a product development team, which focuses more on human factors, on workflow assessments, on what's actually going to be optimal for human AI interaction. That's the type of work they do. And they have software development. Well, we have software developers, we have human factors experts and design experts in that team. And they all work together to go from data to model to product. And lately, we've been getting pressure to try and commercialize. We actually have a commercialization team as well. But one other big thing is that data scientists are terrific, but we have a hard time managing timelines, milestones, deliverables. So we have a project management team that keeps us honest and on track to be able to deliver things and execute efficiently and effectively. What's the process? And as I mentioned, the project ideas and questions come from end users, management and clinical, not from our data science and advanced analytics team. And we will prioritize projects. We have an intake form actually that asks our end users to actually describe the situation, what they think the solution would be, the types of impacts they expect to see. And so initiatives that have promised to improve patient outcomes and reduce costs are typically given first priority. Initiatives that improve patient outcomes at no additional cost are second priority. Reducing costs but not harming patients is third priority. And then everything else, if we have time and energy for it and excitement for it. Now, the majority of projects also have to have senior clinical leadership sign off. So just because one person thinks something is a good idea, and if they're the only one who thinks it's a good idea, it's probably not a good idea. So we have to have sign off from your medical director, your program director, your division and department head, all saying this is important to us as a community. And we're going to work to solve this problem if you can help us. Our typical project duration, we target 3 to 6 months. Some take much longer. Some actually take less time. It's kind of variable. And we typically work on 10 to 15 projects at any point in time. So we're a fairly active group. This is just a visual of the types of projects that we work on and things that we've deployed. I don't expect you to really pay a lot of attention to this. The bottom line is that we work in many, many different areas. So we're not driven by we've got to fix the emerge or we've got to do X or Y. We're more driven by where are our end users engaged and passionate about solving problems. Because when we go from model to deployment, they're going to be the ones using it. And if they're not excited about it, it's not going to be deployed well. So we really go on interest and excitement of end users. I'll give you a few examples. This is actually based on an actual patient at our hospital from a few years ago. A 73-year-old retired banker with an inflamed gallbladder or cholecystitis was an internal medicine patient. And this is something that we see fairly commonly. It should be fairly straightforward. We can discharge them home fairly quickly. We received the advanced gastrointestinal procedure. The plan was to discharge him home the next day. The physician was called at 6:30 that evening because the patient had shortness of breath. So the physician orders chest x-rays and labs. Vital signs were checked twice overnight. The next morning, the physician was called because there was a sudden drop in blood pressure and distress, and the ICU team was called. Unfortunately, Mr. DV deteriorated and died that day. The family was distraught and said we would never have left the bedside. 1 in 12 internal medicine patients will die in the hospital. So the issue is what can be done. When we asked our medical team, they said we could have increased monitoring. We could have looked for signs of sepsis, initiated antibiotics. We could have called the critical care response team and given them a heads up about the patient. If we knew there was nothing we could do for the patient, we could have called palliative care. At least the patient would have died a comfortable, dignified death. And we could have communicated to the patient and to the family. We could have done all of this much earlier, but we didn't because we didn't know. About half of patients that deteriorate unexpectedly. So the other half we kind of know, but the other half we didn't know. So the issue is, can we predict who will die so we can intervene earlier and hopefully save a life? So we did. We have an early warning system that predicts death in ICU transfer. So what it does is, and all of our general internal medicine patients are monitored by this algorithm. We recently launched in another unit, and we're continuing to launch in more units to be hospital-wide soon. We launched in our general internal medicine unit 2 years ago. What the algorithm does is every hour on the hour, it grabs data, typically it considers over 100 features, and it predicts in the next 48 hours, is this patient going to die or go to the ICU? And it categorizes patients as low, medium, and high risk. As soon as it reaches a high risk threshold, it pages the medical team, and the medical team then has to come and see the patient within 2 hours of being paged. And then there's care pathways that they have to decide upon. So again, it runs every hour on the hour, 24/7, and it alarms our team when there's an issue. So we deployed this thing in October of 2020, and we received feedback. Here's one note that we received. The resident on the call overnight received a high-risk alert around 11 p.m. She went and reviewed the chart and saw the patient as per the recommended protocol. But he was relatively stable, so maybe it was a false alarm. Approximately 2 hours later, she received a call from the nurse that the patient was decompensating. As she already knew the patient, she was able to quickly assess at the bedside and get the ICU team involved. The patient went to the ICU but did not, thankfully, have a respiratory arrest, which was certainly a risk if the intervention had not been done as quickly. The resident feels that the AI program made a big impact. Now, these are our actual mortality rates among our high-risk GIM patients over time. If we look to the left, from January to March of 2020, this is when we first started seeing our COVID patients, and this was prior to us deploying ChartWatch. We saw about a 35% increase in mortality compared to the previous 4 years of data. In April to June, we saw many more COVID patients. We saw a 70% increase in mortality. July to September is a good summer, fewer COVID patients, but we still saw a 37% increase in mortality relative to the previous 4 years. We deployed ChartWatch, and despite seeing many more patients with COVID, we saw a reduction in mortality. So we're thinking we hopefully are saving lives through this initiative. So some considerations. Model customization performance. In terms of deployment, performance metrics and evaluation, we really focus quite a bit on things like false positives, false alarms, how is this going to be integrated into clinicians' workflows. All that stuff became really important because what we quickly realized is that if you have a high false positive rate, clinicians are just going to ignore it because they don't trust it. So with other algorithms, what we found is that they would alarm fairly often, 10, 15, even 20 times a day. And in the vast majority of cases, it was false. And so clinicians would just ignore it. So we had to be really focused on, if this is what our human experience is going to be like, then that's probably not going to work. So our solution alarms once or twice a day. And that is far more acceptable to our clinicians. This is why they use it, and this is why they like it, because it's not going off all the time. We also found that with a lot of early warning systems that are available and that exist out there, our clinicians were better. They performed better than the algorithm. So we actually went and spent a few months asking our clinicians, do you think this patient's going to die or go to the ICU? We have over 3,000 clinician predictions. And that's how we were able to know that our clinicians are better than a lot of the other algorithms that are out there. But our algorithm that we created, ChartWatch, performed better than clinician judgment alone. Silent testing and model maintenance, really, really important. We had about a year of silent testing. We were super careful with this one. And model maintenance, how do we know if there's data shift or if the model degrades over time? We have to constantly monitor the algorithm and make sure that it's actually working to the way we think it's working and constantly refine it to improve performance. All sorts of privacy and confidentiality issues. You can imagine some people may not be comfortable with data scientists accessing pretty sensitive data, right? Because if it's Mr. Jones that's going to die, we need to know it's Mr. Jones. It can't be identified. Sorry, de-identified data. Data governance and access. That we have, I would argue, the most progressive data governance framework in the country that enables this nice balance of access and privacy and security. Risk and liability. You can imagine people being concerned, saying, you know, if this algorithm says this patient's going to die, and I don't do anything, do I get sued if they do die? All sorts of discussions around there in terms of liability, legal considerations, and such. Bias and equity. That's a really, really big topic. And I can tell you, we actually looked at how the model performs across age, sex, clinical features, how sick they are, how not sick they are. We didn't have great data on race. We didn't have great data on socioeconomic status. We didn't have great data on gender. So we couldn't really assess there. Now, does that mean that we hold off and say we can't deploy? No, clearly we did deploy because we felt our model was quite robust. What I'm hoping, though, is as we get more information on race, socioeconomic status, gender, that we're able to then assess our algorithm in those subcohorts as well. But because we've seen considerable benefit in our patients, I don't think that's a reason to say, no, we can't deploy these things if we haven't dotted all the I's and crossed all the T's. Another few examples of algorithms that we've deployed: nurse resource team optimization. So simply optimizing the staffing, the size of our nursing pools. We deployed it at 2 hospitals using optimization algorithms. And our estimated annual cost reduction was about $1 million a year, for something fairly simple that was developed, I think, in about 3 weeks or so. Looking at hypoglycemia is not a great thing to experience. These are drops in blood sugar levels or blood glucose levels. And this can often result in disorientation, dizziness, sometimes severely diabetic comas and such. So it's quite an unfortunate thing. And we have a lot of patients with diabetes. So in our vascular and cardiovascular unit, we have dedicated nurses who are fantastic at managing our patients. But, they came to us and they said, look, we need a bit of help with them because oftentimes we just have only so much time in a day and we can't get to everybody, but we need to know who these high-risk patients are. And it's hard for us to understand who they are. So we have an algorithm called Rush. What it does is every day it creates a list of patients for our nurses and says, these are the high-risk ones that if you don't have a lot of time, these are the ones you should focus on. And we asked them, what's a good metric? And they said, well, over time, I just kind of noticed there's a certain proportion of patients that have hypoglycemic events. If we can cut that down to less than 5%, that would be great. And we said, okay. Well, then we took a look at the percentage of weeks that had more than 5% of patients experiencing hypoglycemia. Before deploying the algorithm, it was 9.4%. After deployment, it was 0. It's not to say people aren't having hypoglycemic events anymore. They are, but it's at a much reduced variance than we were used to seeing, which again, I think is very exciting. Another algorithm that we have, multiple sclerosis. We have an AI clinical assistant. What does that mean? So especially for our residents and our fellows who may not be as familiar with our patients as some of our more senior physicians, they often have a hard time saying, look, I'm going to see Mr. Jones at 4:10 p.m. I just finished with my last patient at 4. Mr. Jones has 7 years of history. How am I going to read through all of that to understand what's happening? So we asked them, what would you like to see? And they told us. And we said, you know what? We could do some advanced natural language processing to extract that information within seconds and present it to you as a visual. And so it takes about 3 or 4 seconds, but you will actually have a visual of your patient over that 7-year time horizon to say they had a relapse here and here, and they had 3 over the past 18 months. Or they have new T2 lesions, and they had 1 just show up in the last 6 months. You tried this drug here and here, it failed, then you tried this one, and now they're on this regimen. It outlines all that information in a visual form. And if you're interested and say, I wonder what happened here, you can click on it and it'll bring all the notes from that visit so you can do a deeper dive. All of that is done through advanced natural language processing to make care more efficient for our physicians to be able to provide to their patients. Another algorithm is in our emergency department. Brain bleeds are tough because patients comes into the emergency department, and we're a level 1 trauma center. We have terrific radiologists, a great neuroradiology team, but they're swamped. So what often happens is you get a patient with who have hurt their head. Head CT is ordered, and it takes typically about 3 or 4 hours before the radiologist gets to it and says, oh my gosh, they have a bleed. We should do something about this. That's a lot of time gone. Every second counts. So we have an algorithm now that within 30 seconds is able to get the head CT, look at it and say, yes, there's a bleed. Here's a subtype. Here's where it's located. And what it does is it talks to our radiology information system and color codes that patient in purple and moves them right to the top of the radiologist queue. So you look at the patient now rather than 4 hours from now to help provide better care for our patients. And we've been able to see that when we deploy the algorithm, it's over 70% reduction in turnaround time to radiology diagnosis. So in summary, I'm just going to wrap up here. We created an artificial intelligence lab, which has been really exciting for us, but we moved it one step further. We went beyond hiring data scientists and buying deep learning servers and getting software to creating a living lab where we actually focused very much on end user engagement, on understanding workflows, processes, getting people really involved and engaged, and enabling a data governance framework that allows us to be able to do cutting edge AI. We also spent quite a bit of time developing machine learning operations environment that enables us to efficiently get at the data. This is the non-fun stuff that nobody likes to talk about. That enables us to be able to grab the data we need in real time and feed back things real time to our clinicians. We quickly also realized that we're a single hospital. We would love for our solutions to be deployed at other hospitals and even globally. And we quickly realized we're not positioned to do that. We've got to have a relationship with the private sector. So fortunately, we were able to partner with the former head of AI for TD Bank, who stepped down to actually do a startup in collaboration with Unity Health Toronto, because he's very passionate about making sure that we get these solutions out to people and benefit as many people as possible. So through that relationship, we have a dedicated private sector entity, which is really focused on how do you actually bring these technologies to other hospitals, deploy them in a responsible manner, and keep monitoring and updating and making sure that our solutions are working effectively to provide care to patients when they need it most. And this is how we believe we can provide better care for all of us through artificial intelligence in medicine. And I'll stop there, and happy to have a discussion.
Thank you. Thank you, Muhammad. That was a very thoughtful and thought-provoking presentation, and so much to think about. Just based on all the ground you covered, I mean, really, I have one main question that comes to mind. I mean, you have a very eclectic and a very differentiated background, I would say. I mean, looking at your research journey, there's a focus at one sort of a combination, really, if I can say. There's healthcare and medicine, then there is the artificial intelligence, data science, and then there's the education and science communication. So tell us a little bit more on a personal level about your research journey, your scholarship, and how you found yourself at this very meaningful intersection of these various contexts and domains.
Yeah, thank you. I have taken a bit of an awkward path, to be honest. When I was growing up, I was struggling to find what is it that I want to do. And I went and did a degree in pharmacy of all things. So I have a doctor of pharmacy degree from the University of Michigan in Ann Arbor. I've always liked math. And at the time, what seemed to make a lot of sense is that a lot of decisions were being made by administrators with knowledge in economics and such. So I decided I'm going to do a fellowship in pharmacoeconomics or health economics. And during that time, I kind of wanted to do actual formal training in economics. So during the daytime, I was at the hospital doing my fellowship, and at night I would take classes in econometric theory of all things. So it focuses on mathematical proofs, very intense in that regard, and gained an appreciation of the mathematical theory behind a lot of the models that we use. Then I went to Harvard to do a master's degree in statistics and epidemiology. And at that point, I think I really had enough to say, all right, I'm going to go back now into the real world. It wasn't quite the real world because I was really focused on research and did quite a bit of clinical work as well at Sunnybrook Hospital and at ICES. My challenge was, though, I was never really satisfied with traditional research, because traditional research would give you more average answers for the average person. And we all know in healthcare, the average patient isn't typically the problem. It's the outliers that are the problems. How do we get at outliers, and how do we have customized therapies and decisions for those outliers? Because there's quite a few of them. We call them outliers, but there's quite a few of them. So this is where more personalized approaches, precision medicine was intriguing, but it never really got off the ground, not to the extent that we would like to have. But this is where I was enamored by machine learning algorithms, and AI can customize, can really actually deliver that care for that outlier, for the average person, can really actually deliver what that dream is. And so far, I've been actually quite pleased, satisfied with the impacts that we've been having through AI.
Interesting. Very interesting. Thank you for that, Muhammad. Just maybe if I can slip in one more question, because you touched on this quite a few times throughout your talk. And this has to do with, there's good reason why when we work with healthcare data, specifically patient data, there's a lot of emphasis put on privacy, on confidentiality. We all know why that is. But you also talk about the very interesting tension involved when you're talking about personalization or a recommender engine, which is targeting specific interventions for specific individuals. Then maybe anonymization and de-identification needs to be looked at from a different lens. So in your research, how do you balance this need for personalization as well as then the need for privacy preservation?
Yeah, it's a great question. And I think certain activities will have certain privacy requirements, and rightly so. So for example, research. When you're really focusing on building a model, for example, do you really need to know it's Mr. Jones? You don't, right? And you can deal with the identified data. But when you're deploying and executing, obviously then you need identification. So how do you actually bridge that gap when you're trying to be very pragmatic? And I'll tell you, when we develop models, we'll have a lot of questions around, wait a minute, why is this model not performing well for this subsegment of patients? Who are they? So we need to actually go to the clinicians and say, who are these patients? Like, why are they so different? And so they need to identify who they are so we can actually learn from them. So the way our data governance framework works is that we do have a core team that is allowed access to these data, but it's done in a way where we have all sorts of documents signed and confidentiality agreements and all that sort of stuff, where it is fairly contained. Not many people in the hospital have access, but our team does, because we fall under the quality improvement framework. So the way we work is, yes, we have very good research expertise, but the work we do is so applied that we're in for quality improvement, which enables us through our progressive data governance framework to be able to have access to this data. I think it's also a matter of understanding legislation, what's allowed and what's not allowed. Oftentimes we have many privacy officers and hospital administrators who, to no fault of their own, will say, absolutely not, you can't do it, because there isn't a good understanding of the legislation or understanding of privacy. So when there isn't a great understanding of it, your automatic reaction is very conservative, because you're entrusted by the public with that data, to say no. And I think what we have to do is have a lot more education around what is allowed and what's not allowed to enable access to the right people so we can actually make care better for our patients.
Thank you. That's great. So, Mohammed, in the interest of time, we're going to have to call it a wrap here. But I do want to say there's so many other interesting themes you touched upon in your talk. We'd love to invite you back to talk about, for instance, one of the things I'd love to hear from you touched on it is it's one thing in a lab to train a machine learning model. It's quite another to scale it sustainably so that it's resilient, so it's fault tolerant, it's secure. So there's so much we can dive into there. We don't want to do that right here. So thanks again on behalf of the Synthetic Intelligence Forum community. And we'd love to have you back in a couple of months so that you can continue to share your insight and foresight. So thanks so much for your time, and we hope to see you again soon.
My pleasure. Thank you so much. Really appreciate it. Take care.
Thank you.